Hi everyone, we are Group 26 and the topic for our presentation is antimicrobial resistance caused by fermented food. Our group members include myself Sanya, Su Ernie, Tai Hong En, Yan Nang U, Tan Pao Hung and Tan Yi Jian. So what is antimicrobial resistance? It is the capability of microorganisms to resist the effects of drug used to treat infections. Fermented foods, which have been a long-standing part of global diets, are produced through controlled microbial growth and enzymatic action. They also offer unique flavors, textures, and potential health benefits due to fermentation process. They are widely consumed for their nutritional benefits, but they also pose a dual challenge as they may harbor both beneficial probiotics and antibiotic-resistant microbes and genes, which impact the human health, the food industry, and the environment. Recent studies have highlighted concerns about antibiotic-resistant bacteria and genes in the fermented food. This discovery raises worries, especially with spontaneously fermented foods, where natural bacteria make safety assurance more challenging.
Antibiotic resistance in fermented food is a rising concern. Today, Chef Nick is preparing fermented foods in his shop while Dr. Smith and his two friends, Person A and Person B, are passing by Chef Nick's shop.
Oh, hello. I have prepared some delicious yogurt. Do you want to have a try?
Whoa, these look amazing. I love fermented foods.
Oh my gosh, I heard you Chinese have fermented food, and I'm open to trying them.
Please help yourself.
Hold on, Person A. Due to the compromised immune system, having this fermented food might pose a risk to your health.
Oh, I didn't know, but I love these foods.
But this fermented food contains AR bacteria, which might affect your health.
Sorry, I didn't realize. I'm sorry for the oversight.
Oh, should I be consulted?
For you, Person B, occasional consumption won't cause the same risk as it does for Person
How come?
A. Okay, first of all, let me explain to you about the mechanism of AMR in fermented food. Now we are going to talk about the mechanism of fermented food. Globally, fermented food have become a mainstay of diets due to their numerous advantages, which include improved flavor, extended shelf life, and possible health benefit. However, the unique characteristic of fermented food, such as being consumed raw and having a high density of microbes, raise concerns about the potential risk of antimicrobial resistance. And AMR elements enter human microbiome through fermented foods. They can have lasting effect on microbial communities. The abundance of antimicrobial resistant genes in these products increases due to the fermentation process and excessive use of antibiotics in the food chain. Bacteria in fermented food may possess both intrinsic and acquired resistance. When intrinsic resistance is common, it typically does not compromise food safety. The fermentation environment, characterized by confined space and close cell-to-cell contact, facilitates gene transfer between microorganisms. The starter culture is a significant source of microbes in fermentation, may contain ALG, and raw material used in fermentation, especially in meat and dairy ferments, can introduce microbes with mobile ALGs, potentially originating from animals that are exposed to antibiotics. Raw materials in plant-based fermentation, sourced from soil, water, and manure, may also harbor resistant microbes. Once ALG-containing microbes are present in ferments, there is a possibilities of horizontal gene transfer among the fermentation microbes as demonstrated in control conditions.
Oh, I never realized fermented foods could pose a risk, especially to my compromised immune system.
Antibiotic resistance in this food arises due to various factors, including the presence of antibiotic-resistant strains in raw materials and suboptimal fermentation conditions.
Can you elaborate more about the cause of factor that contributes to resistance in microbial fermented food?
Absolutely, it's a complex issue.
I would like to explain about AMR overview. AMR happens when microorganisms like bacteria and viruses become resistant to drugs, making this drug less effective in treatment infection. And it is also recognized as a global health challenge with serious consequences, including longer illness, higher healthcare costs, and increasing mortality. For the main mechanism, it is quite clear that antimicrobial resistance involves various mechanisms that enable pathogens to evade the effort of drugs, like other drug targets occur when pathogen gene mutate, changing the structure of drug targets so that the drugs cannot longer effectively bind to them. Drug inactivation includes the uses of enzymes by pathogens to break down or modify drugs, rendering them inactive, decrease FT receptors from shift in cell permeability, preventing drugs from entering pathogen cells. For the increased efforts, employ membrane-based to actively eject drugs from cells. So, for summary, this mechanism serves the purpose of enabling the survival and reproduction of pathogens in the presence of antibiotics, undermining the drug's ability to combat infection effectively.
Alright, so let's talk about some causes and factors that contribute to AR in fermented foods. Horizontal gene transfer, or HGT, is a process where bacteria exchange genetic material between species, acquiring new traits. In fermented foods, bacteria can transfer antibiotic resistance genes, or ARGs, through conjugation, transformation, and transduction. While this adaptability creates opportunities for genetic exchange and is beneficial for food production, it also poses a risk of facilitating antibiotic resistance spread. The genetic swapping, driven by stressful environments such as low pH and high salt content, encourages the transfer of ARGs. The presence of ARGs in these environments can potentially transfer to our gut microbiota upon consumption of fermented foods. Once inside the gut, these ARGs might integrate into the genetic makeup of our gut bacteria, potentially limiting our ability to combat infections effectively. Now, let's talk about other factors contributing to antibiotic resistance in fermented foods. The rich diversity of bacteria present in fermented foods also play a pivotal role. Some bacteria naturally exhibit resistance to antibiotics due to their survival mechanisms in these complex microbial communities. For instance, certain strains of Lactobacillus species and Bifidobacterium, commonly found in fermented dairy products and probiotics, show innate resistance to antibiotics like vancomycin and cephalosporin. Historically, antibiotics have been employed in food fermentation processes to control or modify the fermentation. While seemingly beneficial, this practice might contribute to the emergence and spread of antibiotic resistance among the involved bacteria.
Oh my god, this is quite surprising information. I didn't realize that antibiotic resistance could be a concern in fermented food.
I'm sorry for not being aware of the potential risks in fermented food.
I wonder if there are ways to reduce AR in fermented food production.
To address this risk, stringent regulatory measures should be implemented, ensuring safety in food production and minimizing the spread of antibiotic resistance.
Antibiotic-resistant bacteria and genes can be found in large quantities in fermented foods, which may be harmful to your health. To address this, optimize fermentation with safe static cultures, use heat treatments like pasteurization, and apply high-tech solutions like metagenomics for safety checks. Pasteurization is a useful technique for eliminating environmental bacteria that harbor toxins from raw food ingredients. Metagenomics is one example of a high-throughput technology that provides a culture-independent method for identifying uncultured bacteria, finding new ARGs, and conducting a comprehensive safety evaluation. Reducing antibiotic use is crucial to prevent cross-resistance with human medicine, limiting the spread of ARGs in fermented foods. Given the special characteristic of probiotics, probiotic regulations should make sure they are well-defined, non-pathogenic, and do not cause AR. It should assure safety by assessing strength for pathogenicity, toxigenicity, and antibiotic resistance. Innovative strategy against antibiotic resistance in fermented foods includes using non-traditional antimicrobials like bacteriophage, metal-based nanoparticles, antimicrobial peptides, photochemicals, and CRISPR gene-based techniques can be applied.
You know, I was thinking, is there a way to reduce antibiotic resistance in fermented foods?
Yeah, that's a good point. Maybe we could have educational campaign to inform producers and consumers about safer practice.
Yes, I agree. I should start labeling my food with more
information so that people can make informed choices.
Education is key, and advocating for stricter regulation in the food industry could really make a difference. Together, we can ensure safer and healthier fermented food.
As the conversation unfolded, it became clear that antibiotic resistance in fermented food is a significant concern. Dr. Chef, Person A, Person B, and Dr. Smith acknowledged the importance of addressing this issue. For discussing the cost and risk to propose solutions, our group highlighted the need for education, labeling, and stricter regulation in the food industry. Through collaborative efforts, we aim to make fermented food not only delicious but also safer for everyone. The story underscores the significance of awareness and proactive measures in ensuring the well-being of consumers in the face of emerging challenges like antibiotic resistance.